Okay, good morning class. So at this point we're looking at, I gave you two sums for homework, correct? This one here you had to draw on an axis, not so? Right. But we didn't plot this one yet, no? So what I'm going to do is I'm going to draw this up here quickly, so... Okay, so you guys are going to give me the coordinates, okay? So, what is the coordinates? Can somebody give us the coordinates? Where's Gabby? Gabby, go for it. The first sum. Negative 3 and negative 1. So it's negative 3 and negative 1. The next one? Negative 2 and 0. The third one? 0 and 2. The next one? 1 and 3. Next one? 2 and 4. The next one? 4 and 6. The 6 about there. Next one, and that's it. Alright. So what do you notice about this? About these points? It's all increasing. What else do you notice? It's going up. Yes? What else do you notice? They're all points. What else do you notice? There you go, it's a straight line. If I can draw, like a ruler, I can draw a straight line going through all that points there. Not so. Take a ruler and draw that. And now that equation that we drew, which is y is equal to, what's the equation of that graph? Y is equal to? X plus 2. This is the equation of a straight line. That's the equation of a straight line. Can you see that, people? Now, if you look at this here, how many units does this x go across here? 1. And here? 1. From there to there. How many units is this? 3 and 3. So let's see what is the value of y over the value of x. So y is 3 over 3, which is 1. What is this? Y, the delta y over delta x. The change in y over change in x. Here is 1. Sorry, that is the y. So it's 1 over 1, which is 1. If I look from this point here to that point there, what's my change in y here? 4. And here? 4. So the change in y over change in x is going to be 4 over 4, which is 1. So this is known as a slope of a graph. Oops. The change in y over change in x is known as a slope. Okay. Yes. A slope is also known as your gradient. The gradient. And the gradient is denoted with the letter m. So change in y over change in x is m. Make a note of that there. Yeah. Change in y over change in x. Your gradient. Another word for gradient is slope. Okay. You must write this down like that. You see, that's why I say she must be interested. Sorry? Yeah, change is a triangle. But what you notice about this change in y over change in x is 1. That change in y over change in x is 1. Change in y over change in x is 1. So what do you notice? They're all 1. It won't always be 1, no. But in this case, anywhere on the straight line, on this straight line, the gradient is 1. The gradient is constant. It's the same. Okay. So we said M is your gradient. Gradient is a slope. And to work out the slope is going to be the change in y over change in x. Okay? Okay. And then I want you to write M is equal to delta y over delta x. Or change in y over change in x. And this is a triangle. Ne? Looks like a D. No D then. Now why would I put a D here and there? But now you know it's a triangle. D for delta. D for delta. Nice. Okay. Delta y over delta. Nice. Where did you get delta? Did I say? You said delta. Oh, you said D for delta. Delta. Okay. So many times I forget what I said. But yes, that later on you'll hear me say delta on it. It's also to do with the triangle. It's in gradient. Alright. But looking at that delta there, looking at the gradient here is 1. Not so. Where do you see 1 in this formula? In front of? Somebody said it? In front of? You see that? 1x. So the gradient, so we got y is equal to? 1x, which is actually mx. You see, your m was 1. Right. This is hang on, man. You're too fast for me. Okay. Right. Now let's look at this here. What is this? This is where the graph cuts your y-axis. Can you see that? What's your value for y? What's the value for y? 2. Isn't that the 2 here? And that is your the 2. So that value will be where it cuts your y-intercept. And that is your C. And this is your standard form of your equation. So right here, standard form. The standard form of a straight line graph is y is equal to mx plus c. Right. Y is equal to mx plus. Okay. Then I gave you another sum yesterday to do, not so? So yesterday, the second sum was given as -2, -1, 0, 1, 2, 3, and the y value of -6, where the equation y is equal to -2x plus 1. So let's look at this here. Okay, before I go anywhere else, let's make another thing here. This graph is increasing or decreasing? Increasing. Okay. Let's make another note. The graph is increasing. How do I know the graph is increasing? It's going up. And we always read it from the left to right. Can you see it? We always move in this direction. So the graph is going up. So it's increasing. We always move from left to right. No? The graph is increasing. Now let's look at the next one. Interestingly, okay, we first bring that page number down. This is not on this page, but that is what was explained basically around about this page. Okay, it's not 64, but the idea is being exposed to this idea on page 64. Okay. So, for those of you who did the work, what is the first value? 8. You all got 8.
Yes.
I don't need to explain how 8, no? The next one? 6. Then? 4. Okay? 2. No. Let's see. Y equals negative 2 times 0 plus 4. Negative 2 times 0 is negative 2, not so? No. 0. The answer is 4.
So that's why.
Yes, that's your mistake you made.
Oh, she's
Yeah, she's that. Yes. But you didn't do it, so do your work, no? Right. Next one. 2. Then 0. Then negative 2. Then okay. So some of you giving different answers. Okay. So if you got y is equal to negative 2x plus 4, is this negative 6 an x or a y? It's a y. So I put it on y's place. So I said, Lisa, can you my go? Are you taking me for a fool? Are you taking me for a fool? So why did you do that now? Huh? Do I look like a joke to you? So y is negative 6. So you got negative 2x plus 4. So what do we need to do here? To solve for x. X is one side, number the other side is the quadratic a linear equation. So negative 6 minus 4 is equal to negative 2x. So that's going to give you negative 10 is equal to negative 2x. Divide by negative 2 both sides. So x works out to be 5. That is 5. You all understand? Right. So the next step was to write down the ordered pair. Not so?
Yeah.
Another word for ordered pair is what? Coordinates. Ordered pair and coordinates is synonymous, is the same thing. Not so? Ordered pair and coordinates. And coordinates is always written as x first then y. Not so? So the first ordered pair would be, for that there would be negative 2 and 8. The next one? Negative 1 and 6. The next one? 0 and 4. The next one? 1 and 2. The next one? 2 and 0. The next one? 3 and negative 2. The next one? Negative 6. Okay. So you guys then had to draw it on the, what do we call this here? You must graph it. What do we call this here? Kinetic? Yes, there we go. It's a Cartesian plane. Okay, so again, Gabby will give us the values. But now I got this yesterday already, not knowing that I needed actually more to extend it. Okay. So I'm just going to plot the points that is within the given graph. Okay? Yes? After the sum. Okay. So what's the first coordinate? Gabby? Negative 2 and 8. So that is completely off. Now you guys will go negative 2 and 8 is much higher there. No? Next one? Negative 1 and 6 is approximately. Not so? Negative 1 and 6. The next one? 0 and 4. Next one? 1 and 2. Next one? 2 and 0. The next one? 3 and negative 2. The next one? 5 and negative 6. The negative 5 is there. The negative 6 will be a bit lower than that. 5 and negative 6. So what do you notice now? Yes, it's decreasing. It's a straight line. We can draw it in a straight line through those points. Can you see that, people? Let's draw. And there's your graph. Can you see that, people? The straight line can be drawn through this here. Okay. It's decreasing because as you're moving from left to right, the values are getting smaller. It's decreasing. Whoops. So it's a decreasing graph. Not so? If you go, you're changing, or have a change in x, so your gradient. You look at the gradient here. Remember what's in that equation? Y is equal to negative 2x plus 4. Yeah, that was the equation. So if you go here, what's your delta y? 4. And your this here? 2. So since it's like decreasing, it must be minus. So it's negative 4 over 2, which is negative 2. Let's take it from this point here, all the way down to that point there. So your gradient here, what's your change in y here? You're going from 6 down to minus 6. So what's this length here? 12. And you're going from minus 1 to 5. So what is 6? And it's negative. So it's minus 12 over 6, which is negative 2. So again, what do you notice? It stays the same. So anywhere along that line, the gradient will always be the same. It will be, if something stay the same, what do we call it? Constant. So the gradient is constant. Can you see that? So anywhere along that line, the gradient is the same. And if you look at this gradient, is negative 2. And there is negative 2. Can you see that, people? And how do you work out the gradient? It is delta y, delta x. So change in y over change in x, always. Okay? It's your gradient. And then, you see here, what's your y-intercept here? 4. And what do you see there? It's 4. So your c value is going to be, so your c value is 4 and your m value is negative 2. Okay? You guys understand? And we see the graph is decreasing. Okay? This is also known as your, you see this point here is known as your x-intercept. Make a note there. Why is it x-intercept? This is basically where the graph cuts the x-axis. Can you see that? So what is your x-intercept? Is the point where the graph cuts the x-axis. So make a note there. And what is this would be then your y-intercept. Your y-intercept is where the graph cuts your y-axis.
So isn't the x-axis one?
No, this is your x-axis. This whole line here is your x-axis. And this whole line here is your y-axis. You understand? So make that note there, people, about your x and y intercepts. I'm going to show you something else also now. But when we do examples, when you'll see how all of this fits in there. Yes? Sorry? Repeat. Okay, so you see we said x-intercept. Your x-intercept is where the graph cuts the x-axis. Can you see that? Your x-intercept is where the graph cuts your x-axis, and your y-intercept is where the graph cuts the y-axis. And there you can see there's y and there's x. Yes?
So is it intercept or intercept?
Intercept. Y-intercept. Intercept. Yeah. Let me see, maybe I could get it. as an intercept. Yes? Intercept. Yes? Why intercept? Okay. It's not plugged in. How can it not be chosen? Now, this thing is plugged in here. It must go into the wall. No. People, will this ever charge like this? No. Pleasure. Okay. Intercept. Okay. Right, so what else wanted to look at this here. Something else before we move on with our lives. Okay. What's the coordinates of this point here? 2 and 0. What's your coordinates of this point? 0. So what do you notice? Anywhere on your y axis, x is 0. Can you see that? Anywhere on your x axis, y is 0. Can you see that, people? Right. And that, with that idea, later on we're going to draw these graphs. Okay. With that in mind. Okay. That is page 64. So I want you to make this note here. That the graph of a linear function, namely y is equal to mx plus c, is a straight line. Okay. So we spoke about the plotting of points, we spoke about that there on page 64, standard form. So a note I want you guys to make. We're on page 65 now. The girls that's talking in the background, please stop if you don't mind. Yes? Sorry? Slowly. Okay. So this note I want you guys to write down quickly. Standard form, y is equal to mx plus c. It was on 3, sorry. Standard form is y is equal to mx plus c on page 65. M, we said m is your slope, gradient, or it's also known as your inclination. Have you heard of angle of inclination yet? We'll speak again about that. Okay? Inclination. C, what did we say C is? Your y-intercept. It's also where the line cuts the y-axis.
So what's the x-intercept?
X-intercept, that must be calculated. But the y-intercept can just be read off from the equation. Okay? Okay? You see, here we are told that m is greater than 0. What does that mean if they tell you m is greater than 0? Then that means to say you put here in brackets that m is positive. Not so? So if m is less than 0, that means you say m is negative. Okay. So that two goes together, and these two goes together. And if m is equal to 0, one of those two occur. Okay. The other one's actually where m is undefined, but for now just leave it as m is equal to 0. Okay. Then we see that m is delta y over delta x, or change in y over change in. Yeah, just draw it roughly. Okay. There's a note I need you to make that quickly before we go into the next part of the book.
Okay. So
we see that if m is greater than 0, if m is positive, the graph is increasing, and if m is less than 0, the graph is decreasing. Or we can say if m is positive, or the gradient is positive, the graph is lying to the right, and if m is negative, the graph is lying to the left. Okay. And if m is equal to 0, it's either then parallel to x-axis or to the y-axis. Okay, one of that is not correct for now, but we're just going to leave it like that for now. Okay. At one point, one of it is has a gradient which is undefined. But we don't want to talk about that now. Okay. This is looking at the examples on page 65. The question says, write down the gradient and the y. You must remember, the standard form of equation is y is equal to mx plus c. They want you to write down the m value and the c value of each equation. I'll do the first one. Number 1, the gradient is going to be 3. And your y-intercept or your c value is negative 2. You guys understand? Now you do the next 4 for me, please. The next 3, sir. Or make the next one. Okay, do that for me quickly. Well, that fit. They're always in the way. Alright, you guys finished? Yeah?
Do you have to ever see just the M equals?
You always have a C. So number 2. Your M value is 4 and your C value? Your number 3? 3/4. And your C value? Zero, none. Because if I draw this graph, it's not going to have no y-intercept. It's going to have a y-intercept of 0. Okay. Number 4. Gradient is -1. And your C value? So that is where it's going to cut your y-intercept. Number 5. The third is? Now the next one, if you look at the next question. Number 6. Can I take the M value as a standard then? What's your M value number 6? The question is, you're saying it's 2. Okay. My question is, for you to read off the M value, it has to be in the form of y equals mx plus c. Not so? It has to be in that form. Is the equation in that form? No. So do we have the M value? No. The first thing is we need to get it into the standard form first. You understand? First get it in standard. So how do we get it in standard form, or making it that y is the subject of the formula? You first I get x over. So I got 2y is equal to 4 minus x. So it's minus x plus 4. Remember, that's the form I wanted in. Okay. Now is it in that form? No. What's the value in front of y here? 1. I must get it in that form first. So what do I divide? There we go, divide by 2. So therefore, y is equal to negative x over 2 plus 2. So what is your m value now and what is your c value? Write that in. Yes? I think you come to the maths class just to eat papa and to drink water. You only do every day. So what's your m value? See? Do for me number 7. So again we must get in the form of y is equal to mx plus c. I start by taking that over. So negative a third y equals negative 2 plus 5. How do I get y on its own?
So don't you like do the reciprocal of a third?
You can't do reciprocally. Not in this case. Only time you can do a reciprocal if you've got a fraction on either side of the equal sign. So you can become x over y is equal to b over a. Is that what you're talking about? That was the reciprocal. Now you're swapping it around. You can't swap it around here because there's 2 terms on the left and the right hand side. So I'm going to divide throughout by negative a third. So that cancels. So y is equal to, now negative 2 divided by negative a third is the same as negative 2 times. Take its reciprocal, negative 3 over 1 is negative 3, which give me 6. 6x. Then you say 5 divided by negative a third is equal to 5 times negative 3 over 1, which is negative 15. You all agree with that? So, what is my m value? What's the gradient? 6. And what's my y-intercept? Alright, you guys understand?
Sir,
Yes?
where is the 3? Where is the 3, sir?
I must divide it here by negative a third throughout. But you understand? Right, next. The graph of y is equal to mx plus c using the intercept method. That's your next subheading there. The graph of y is equal to mx plus c using the intercept method. I need you to write this down. Method number 1, y-intercept, let x equal to 0. Number 2, x-intercept, let y equal to 0. Number 3, plot the 2 points and draw the graph. Okay, yeah, put it on the group. We will carry on with this tomorrow, okay?
Okay, good morning class. Enjoy the rest of your day.